We just saw a solution of this problem where we had a compound inequality that was glued together with an and. So what if we were to do the same exact problem, but instead of an and connecting these two inequalities together, we had an or? What would having the word or here change about your process? What parts of this problem solving would remain the same? Let me start with that. What don't we have to change up here on the screen? The good news is that having an and versus having an or is not going to change what you do with each of the inequalities separately. You can still solve each one of those inequalities to get the variable by itself. All the steps that we did over here on the left are still the steps that we want to start with. And so it's not until after you've solved that inequality that now we need to worry about what this or is going to do for us. So what do you think is the difference? When the word was and instead of or, we were looking for those values of y for which both of these inequalities were true. What do you think is different when we use or there instead of and?
Only one inequality has to be true.
Exactly. Those of you thinking about a major in computer science might have already thought about how ands and ors are different from one another. It's one of the first, most basic things in logic, right? That in order for two things to be true anded together, they need to both be true. In order for it to be a true statement that I have, an iPad and a laptop, I need to show you that yes, I have an iPad and that yes, I have a laptop. Both of them have to be true, or else I can't claim that I have one and the other. But in order for an or to be true, if I walk in the door and I say I have an iPad or I have a laptop, what kind of evidence do I need to present? One or the other. I can show you just an iPad and my sentence is true. I can show you just a laptop and the sentence is true. I can show you both of them and my sentence is still true. Right? The only way to prove that statement wrong is to show neither. Right? So when you're oring two things together, we need to find the y values for which either or both are true. It's what logicians call an inclusive or, because both is still okay. But the point is that we have to have at least one be true in order for the or statement to be true. So I'm going to erase all of my purple stuff up here, if I can. There we go. And thinking again about which values of y are going to satisfy both, not both, but one or the other of the red and the blue. Instead of looking for the overlaps now, instead of taking just the overlaps, we're kind of gluing both of these sets together and taking everything. So does 3.1, for example, satisfy the conjunction, the disjunction, the or? Is 3.1 a y value for which either of those two are true? Does 3.1 belong to the blue set? Yeah. So actually right away we can say yes, it belongs to the disjunction of the two, right? The or is satisfied by 3.1 because 3.1 is part of the blue set. What about 3? If we scoot that 3.1 backwards to 3, does 3 belong to the disjunction of these two sets? Why, Darren? Yeah, you're already looking ahead at the answer. Yeah, exactly. 3.0 belongs to the disjunction because it doesn't belong to the blue set, but it does belong to the red set. So it belongs in the disjunction of the two. And so does 2, so does 1, so does 0, so does negative 1.2, so does negative 2.6, because all of those belong to the red set, even though they don't belong to the blue set. And so Darren is looking ahead at the final answer and saying if I stick both of these sets together using an or instead of an and, then in fact everything to the right of negative 3, because it belongs to the red set, will automatically belong to the disjunction. And everything which belongs to the blue set already also belongs to the red set. And so of course that will also be a part of our final answer. So now we're gluing these two intervals together. If we were to express our answer as an inequality, what y's would we want to be a part of the solution? We know negative 3 is somehow important in this. What inequality symbol do I want in between these two that will express those y's which belong to one or the other of these two sets. What should I put in between the y and the negative 3? Which y's belong to my purple set? Those y's which are... Those y's which belong to this solution are those y's which are greater than negative 3, and also y equals negative 3 is also a part of this solution. Right? And again, when in doubt, we can just explicitly ask about negative 3 itself. How do I know negative 3 is a part of the solution? Which of these two sets does negative 3 belong to? Belongs to the red set, right? Because it's greater than or equal to negative 3. And then we shade everything to the right. And that gives us our solution, charted on the number line. What does that look like as an interval? What's my leftmost endpoint for this interval? Negative 3. What's my rightmost endpoint for this interval? It keeps going. There is none, so infinity, comma. Infinity gets what kind of bracket? Always rounded. What does negative 3 get? Square bracket. And how do we know it gets a square bracket? Yeah, because it's actually included in our answer, greater than or equal to, which we displayed on the picture up here as a closed circle. So we got a very different answer at the end of this work just by changing the and to an or. So if you work one of these compound inequality problems and you don't end up wrestling with the question of do I take the overlaps, if it's an and, or do I glue everything together, if it's an or. If you don't, if your brain doesn't come across that question in this process, then chances are you didn't do enough work, or you might not have done the right work. Right? So you only found a part of the elephant, but you didn't see the whole thing.